Okay, so this week topic is bitumen. Am I right? Why we need to learn about bitumen? Why we need to learn about bitumen? In pavement design, why the bitumen is important for pavement design? It's the binder that we use in the flexible pavement, isn't it? So in the flexible pavement, we bond the aggregates together using bitumen. In the rigid pavement, we bond the aggregates together using cement and water. So it is important to know about the bitumen. So what is bitumen? It's an industry byproduct from the petroleum industry, am I right? So we won't be able to control the properties because it's the industry byproduct. However, we should be able to select the right binder type for a specific application. And we call it is a viscoelastic material. What do we mean by viscoelastic material? It's changing the viscosity with the temperature. So in cold climates, in cold temperatures, it's like a solid, but when you heat it up, it will become a liquid, isn't it? So when we're looking at bitumens, we are going to do two things. Like, we need to know how to select the right type. There are different types of bitumen, so we should know how to select the right type, and also we should know how to select the right amount, right percentage. So you will learn how to select the right percentage during the practical class, and we are going to, in the tutorial class, we are going to learn how to select the right binder type for a specific application. Are we good? Any question? So these are the things you have discussed in the lecture. Am I right? So we already know what is bitumen. And do we know the chemical composition of bitumen? There are 4 chemical compounds in bitumen. Do you know the 4 compounds? Yes, so we have a question, we are going to write the answer. So they have different characteristics. Like there are 4 components in cement. Do you remember the 4 components in cement? C2S, C3A, do you remember them? So you have quiz next week. So similarly, we have 4 components in bitumen. We are going to learn what are they: asphaltenes, aromatics, resins, and saturates. So we are going to learn about them. And the bitumen can be in 2 structures. They can be like a solution, and also bitumen can be like a gelatinous structure. So salt structure and gel structure. We are going to learn about this one as well in the tutorial. And it is very important to know about the bitumen properties. We are not going to go through this in the tutorial class. However, you have learned the physical properties, modulus of stiffness, durability, and the adhesion in the lecture. Adhesion properties are very important because that's our main purpose of having bitumen, to bond the aggregates together. And also there are different bitumen types. There are 3 conventional bitumen types in Australia that we use. Do you remember the 3 types? No? Okay, so we are going to talk about that. And also, depending on the viscosity, we divide them in, like, we have 3 types. And also, we can mix this conventional type and we can have multigrade binders with improved properties. And also, we have polymer modified binders where we add a polymer to improve properties. And also, there are 3 types of cutback bitumens, emulsions, and also there are additives that we can add to bitumen to improve properties. So you have discussed all these in your lecture. And we need to learn, as I have mentioned at the beginning, we are going to learn how to select the right binder type for a specific application. When we come to that question, I will explain you more. And also you discuss about the testing of bituminous materials. It's very important to test the material and find the properties. So you have covered that part in lecture. Do we have any question regarding the summary or else any of these things? No? Then you should be able to answer all the questions, okay? So, so let's see. Okay, so we discussed that there are four things in bitumen. So what are the four things? Asphaltenes, resins, aromatics, and saturates. So if you look at these four things, asphaltenes are brown or black solid. They are solids and with high molecular weight, and they are very polar molecules. These are from your lecture notes. And the resins are dark brown solids or semi-solids. They have medium molecular weight and high polar molecules. Aromatics are dark brown liquids. They have low molecular weight and have a ring or chain structure. Saturates are light colored liquid, low molecular weight, have straight or branch chain structure. They are nonpolar and have weak van der Waals attractions. So when we consider asphaltenes together, we call them micelles. Have you heard of the name micelles? So we say micelles are dispersed in the maltenes, which is the oily phase. This maltenes or the oily phase consists of resins, aromatics, and saturates. So that's the structure of the bitumen. Is that right? So your first question in the tutorial is about the four components, which are asphaltenes, resins, aromatics, and saturate. And the second question is about the structure. So we have discussed everything. So you should be able to answer the first two questions by yourself. So can I give you a few minutes for you to answer this question? List the four chemical compounds in bitumen and briefly explain their characteristics. So what are the four components? Can I give you a few minutes for you to write the answers? Yeah, so what are the four things? Asphaltenes, resins, aromatics, and saturates. Anyone have any question regarding the four components? So what are the characteristics? They are asking about the characteristics. So what are the characteristics? Yes, so we need to know the phase. Phase means whether it is a liquid or a solid. We need to know the color, black, brown, light brown, no light colors or whatever it is, molecular weight, and the atomic configuration. So we discussed everything in the previous slide, didn't we? So can you please write down this? So this is a good exercise for your next week quiz. Yes, this topic is included in the quiz. This is topic 5. No, this is fine. So if you look at asphaltenes, are there solids, liquids, or what it is? Are they gas, liquid, or solid? They are solid. And what color are they? Black or brown, dark brown or black. Molecular weight, are they high molecular weight or low molecular weight? High molecular weight. How about the atomic configuration? Are they polar or non-polar? Van der Waals attractions, what they are? High polar. Very polar molecules. How about the resins? Yes. So what phase are they? Solids or semi-solids? Boys, you can answer the questions. If you really want to talk, you can answer these questions. Are they solids or semi-solids or what? Semi-solid to solid, solids to semi-solids, and they are dark brown, medium molecular weight, and high polar molecules. Is that right? How about the next one, aromatics? They are liquid, dark brown, low molecular weight, and they have ring and chain structure. How about the saturates? Liquid, light color, low molecular weight, non-polar with weak van der Waals attractions. Is that right? Okay. Any question regarding this one? Okay. Question number 2. Briefly describe the colloidal system of bitumen. What are the differences between salt structure and the gel structure? So leave the second part. We already discussed about the structure, colloidal structure. So can you please write as you understood? Whatever the thing that you have understood, you can write it down. I will then explain again. So we discussed about micelles. Micelles dispersed in an oily phase. We call that maltings. And these micelles are consist of aromatics, sorry, asphaltenes, and the oily phases consist of aromatics, saturates, and the resins. So micelles are dispersed in the oily phase, which consists of. So did you write it? So they stay like this. So these micelles, which are asphaltenes, they are dispersed in the oily phase, which you call the maltines, and it consists of resins, aromatics, and saturates. Are we good? Any question? So your next week quiz is a closed book, so you need to put things in the head, not the photos. It's a paper document. It's a closed book. What's that? Okay, let's move to the next part. Salt structure and the gel structure. Anyone know the answer for the salt structure and gel structure? What do we mean by salt structure and gel structure? Okay. So in the salt structure, salt means solution. So in that one, the micelles are individually dispersed. So they are not connected. But in the gelatinous structure, do you know the difference? Do you know gelatin, jelly? Yeah. And yes, so these micelles are connected in the gelatinous gel structure. So it has a network connected to each other. The micelles are connected to each other to form a network structure in the oily phase. So that's the difference between the salt structure and the gel structure. When we have more asphaltenes, we have a gelatinous structure. When you increase the asphaltenes in a salt structure, then it will become a gel structure. Bitumen has all 4 things together: asphaltenes, resins, aromatics, and saturates. All 4 together we call the bitumen. Oh, good. Any other question? Third question, list the 4 major causes of hardening or aging of bitumen, and how do each of them cause the hardening or aging? Yes. Yes. So what do we mean by hardening? Yes, harden means get hardened. So why it is a disadvantage? Why don't we want, why we need to, like, why it is an issue, hardening of yes. Flexible, as the name says, we need to have a flexibility. So in the rigid pavement, we have concrete, so it's a rigid one but in the flexible pavement, we need to have that flexibility. So it's not a huge flexibility, but when the tires are moving, the flexible, it should be flexible. Otherwise, it will crack, isn't it? So what are the causes of getting hardened? The bitumen get hardened. One is the oxidation. What do we mean by oxidation? Yes, so bitumen can react with the oxygen in the environment, and that can form more asphaltenes. So asphaltenes is the hard solid part, so that because of that, the bitumen will get hardened. It will, yes. Yes. Increase what? But if you form new particles, it is increasing the weight. But if it is evaporating, yes, it is decreasing. If if it is absorbing into the aggregates, again the bitumen, it decreases the binder content separately. Oxidation, any question? Last table, what do we mean by oxidation, boys? You get 5% for Q4. That 5% is only given when you actually participate in the study. What do we mean by oxidation? Yes, reacting bitumen with the oxygen in the environment. And what is the next way? Okay, oxidation is that. What is the other three ways? Loss of volatile components. So this bitumen is a volatile material. What do we mean by volatile? It's evaporate like petrol evaporates. So likewise, it is a byproduct of the petroleum industry. So that has volatile components. Those volatile components can evaporate to the environment. So because of that, the oily phase get reduced. So the bitumen will get hardened. What are the other ways? Two more ways. What do we mean by physical hardening? Yes, with the time, the molecules will reorient. The reorientations can happen in the molecule so that it will get it will get hardened. The last one is exudative hardening. Exudative hardening means the movement of the oily compounds into the mineral aggregate. So if you look at aggregates, they are with tiny pores. Am I right? So when we add bitumen to aggregates, aggregate can absorb the oily phase into the aggregate pores. That when it is absorbed into the pores in the aggregates, they won't be able to contribute for the bonding process, isn't it? So you have discussed that in the last week concrete mix design as well. Whatever the absorbed water, they can't contribute in the hydration process, isn't it? So you deducted that amount, that's 0.5 or 0.7, whatever you had. You remember that? Okay. Question number 4. What are the major applications of the 3 standard grades of bitumen in Australia? There are 3 conventional types, standard grades. What are the three standard grades that we have in Australia? What it is? Yes, class 170, class 320. Yes. What that number means? 170, 320, and 600. What is the? What's that? Elasticity. What is that? I never have heard it. Different performance and different. Viscosity, isn't it? So this is the viscosity at 60 degrees Celsius. What do we mean by viscosity? Viscosity is the resistance to flow. So if you look at water and honey, which one is more viscous? Honey. So if you look at these numbers, 170 and 600, which one is thin, which one is thicker? 600 is thicker and 170 is thin, isn't it? So for example, if we only have these 3 types, and if I ask you to select the best type among the 3 for a spray sealant, which one you recommend? For a spray sealant, at the top of the pavement, you do a spray sealing work. 600. Why the 170? Why the 600? First tell me why you selected. Who said 600? Why you select 600? I am looking for something as a spray sealant, not a heavy duty use. So is it easy to spray 600? If I give you honey and water, which one is easily sprayable? Water. So 170 is the one which can be easily sprayed on the surface. it has less resistance to flow between the layers. And if I ask you to find a hot mix, I'll explain you what is hot mix if you don't know. Uh, for an airport, the planes are going on the pavement. So what kind of a thing is like, which one you recommend? 600 for very heavy duty applications, isn't it? Okay, so if we summarize the applications, 170 we use for spray sealing in cold climate and also for light traffic applications. 320 we use for hot mix asphalt in high service temperatures and heavy traffic. 600 is for heavy duty applications. Are we good? Any question? No questions? Okay, so these are general applications. However, when we are selecting the right binder type, we use the OSROAD guidelines to do that. We follow the tables in the OSROAD. We are not going to just select one from the 3 conventional type. We have to do it in the right way. So we are referring the tables in the OSROAD. So when we are referring the tables in the OSROAD, we need to know a few things. First thing is we need to know what kind of application it is. So are we looking for a binder for a hot mix, or whether we are looking for a binder for a cold mix, or else whether we are looking for a binder for a spray sealant? So you know what is spray sealant, isn't it? Spray sealant is on top of the pavement layers, you spray. So that is a spray sealant. So what do we mean by hot mix and cold mix? What's the difference between those two? Just aggregates. So in the hot mix, what we do is when we are doing the wearing course or base course, or else the uh, base course or the intermediate base course or the intermediate course, we for a new pavement we heat and we mix the bitumen and the aggregates in the site. So we need to have the machineries and we need to have all the equipments to heat and mix while we are doing it in the site. And it is it's not economical like cold mix. In the cold mix, what we do is we need to heat the binder to mix with the aggregates. Otherwise, it won't mix properly. You will see it when you do the practical. So we heat it and mix it in the plant, and we bring the cold mix to the site and we use the cold mix, not the hot mix. So cold mix is used for maintenance because it's cheap and it's not that strong like the hot mix. So for if you are doing a pothole patching, no point of bringing all the equipments and do a hot mix there. We bring a cold mix and we do the right, we follow the right process and we patch the hole. But hot mix we are using for wearing course and also base course and intermediate course. So first thing that you need to know is you need to know whether you are finding the binder for which one, whether for a hot mix or a cold mix or for a spray sealant. Then you need to know if you are looking for a hot mix, you need to know whether you are looking at the wearing surface or whether it is base course or intermediate course. So depending on whether you are looking for a binder for a wearing course, you have to use a different table. You can look at your lecture notes. If you are looking for a binder for a base course or intermediate course, then you have a different table to refer. Is that make sense? What that? Sometimes, yes. Sometimes you can use aggregates like without bonded, and also you can have cemented aggregates. You can have both depending on, and also there are some applications when you do the second practical, you will get to know. We will do with circling. We have deep all the layers with the binder. Okay, so there are different. You mainly like your sub base doesn't have to be just aggregates. It can be cemented aggregates. It can be with bind as well. Any other questions? No questions? Okay, and also there are few more things that we need to know. The other thing is traffic condition. So traffic condition means how many number of vehicles per lane per day are expecting. And what else we need to know? We need to know this also to find the right binder type. What else? Temperature, that means we need to know the maximum service temperature. That means we need to know whether we are designing for Sydney, Hobart, Melbourne, or where we are going to build our pavement. What else? There is one more thing. So 3 of you at the back, do you know the answer for the last part? We need to know the site severity. What do we mean by site severity? We need to know whether we are designing for a free-flowing site, whether it is if it is a freeway, just vehicles are freely moving. If it is a T-junction, what will happen? Vehicles are stopping and starting, isn't it? It's different. If you have a roundabout, it's different. So we need to know what kind of what kind of a site it is. So we call that the site severity. We need to know all of this to find the right binder type. So we need to know whether we are designing for hot mix, cold mix, or spray sealant. Then we need to know if it is a hot mix, we need to know whether we are looking at which layer, wearing course, or else the intermediate course or base course. And spray sealant is always on top of the layers. And cold mix is always for maintenance. And also we need to know the traffic category, how many vehicles per day per lane. We need to know the maximum service temperature, and also we need to know the site severity. Any question? No questions? Okay, so this is what I have explained you. So you guys need to put them in your head. So everything is in your phone. Okay, now tell me, this is your question. Next question. So tell me what the things that I need to highlight here. Do we know whether it is a hot mix, cold mix, or a spray sealant? Is it given to us? Yes. Yes, so we are looking for a hot mix. Have they mentioned about the layer, base course or intermediate course? It is not the wearing course. And have they mentioned about the site severity? Free-flowing vehicles. And have they mentioned about the traffic condition? Yes. Have they mentioned about the temperature? Sydney. Okay. So you don't have to worry about this part yet because you haven't learned it. ESS stand for equal standard axles. You will learn it in future. Okay. So don't worry about it. So with these parts, now you can select the right binder type. Can you refer your lecture notes and tell me for hot mix, there are 2 tables for hot mix in your lecture notes. One for wearing course, the other one is for base course and intermediate course. So which one you select? There are 2 tables. Which one need to be selected? Table for the intermediate and base course, or for the table which is for the wearing course? Which one? Intermediate. So you select this, right? Not the other one. Am I right? Is this the table you select? Okay. In this one, how can we find out the binder type? Can you guys find me the binder type, please? You may get a question like this. So if we know the maximum temperature and the traffic category, you will be able to find the right binder type. Do we know the maximum temperature? We know it as Sydney, and we need to know whether it is high, medium, or low, okay? And the traffic condition, we know it is 2,500 per day per lane. And we need to know whether this 2500 means light, medium, heavy, or very heavy. Am I right? So there are other two tables to find these two. So do you see that in your lecture notes? So now these are the two other tables. Now, considering all three tables together, can you please find me the right binder type, binder, set of binders that we can use? Okay, so Sydney temperature is what? Is it high, medium, or low? Medium. Where do you see the Sydney? So that one is here, isn't it? And how about the traffic condition? We have 2500. That is this one. How about the traffic, the site severity? Free flowing. So that is very heavy. So this is very heavy and this is medium. So you can use, you are going to write all this. If you get this question tomorrow, next week, you have to write all of them, okay? So tables will be given to you, but you need to know the procedure to do that. Which table to select and how you will do it. So what are the binder types we can use? C320, C600 multigrade and polymer modified binders. Any question? Okay, so are we all good? Then can you please try the next question by yourself? I don't think you need my help now. So are we looking for, do we know the application? Vehicles, T-junction. You need to select the table for spray sealing work, am I right? So spray sealing table is this, isn't it? So, have you selected the right table? Okay. So now tell me your traffic category, site severity, and also temperature is high. It's already given to you. So that will be this column anyway. So these are the two tables for you to find the traffic category and the site severity. Traffic category is what? T-junction, where is the T-junction? Moderate. So that will be multigrade and polymer modified binders. Is that right? Any question? No questions? Okay, so if we summarize what we have done here, if we summarize it. So if you are designing for a hot mix, if you are looking for a binder for hot mix, in your lecture notes, you refer the table 7.1 for varying course and table 7.2 for intermediate or base course. So these table numbers are same in the Off-Road guide. So if you look at the Off-Road guide, it's in your views, you can find it. So that will be 7.1 for varying course for hot mix, and also for base course and intermediate course, it is 7.2. For the cold mix, actually it is for maintenance. So you can select one of these for the cold mix. And for spray sealant, you need to refer the table 7.5. For finding the traffic category and the site severity, you need to refer these tables depending on whether it is a hot mix or a spray sealant. Are we good? Any question? No questions? Okay, so that's all from my side. If you have any question, we can discuss. Otherwise, if you are fine, we can wind up the class early.